In this example, we'll take another look at u-substitution, but in this case, we're going to involve some trig functions. Suppose I want to find the integral of sine cubed of x. The problem here is we're always looking for this function derivative pair, where one part of the expression is the derivative of another part. The problem we're having here is that I just have sine. Sine is my basic function, and in order to use sine, I really would like to see a cosine somewhere floating around, but I don't have a cosine, so the question is, am I stuck? What do I do? Well, one of the things I can remember is that there's this handy little Pythagorean identity that says sine squared x plus cosine squared x equals 1. And remember, that's actually derived from the Pythagorean theorem, so it's called the Pythagorean identity. Now, the nice thing about this is it involves sine and cosine. It relates them together. So what I'm going to do is I'm going to take the expression I've got here for sine cubed of x, I'm going to break it apart into two pieces so that I can have both a sine and a cosine involved in the expression. So what I'm going to do is I'm going to write this as the sine of x times the sine squared of x. What that does for me is I can now replace this sine squared guy with something that involves cosine. So since I can say sine squared of x is equal to 1 minus cosine squared of x, okay, from that identity above, I can now say I have the integral of sine of x times the quantity 1 minus cosine squared of x dx. Now what this is going to do is I can say if I let my u be cosine, then my du is going to be the derivative of cosine, which is minus the sine of x dx. Now, unfortunately, I do not have a minus the sine of x dx, but I can put one in there, and I can say I can put a minus out in front, and then put minus sine of x here times 1 minus cosine squared x dx. Okay, so all I did was change the way it appeared. I multiplied it by really 1, because negative 1 times negative 1 is positive 1. So I haven't changed the integral at all. I just changed how it looked. Now what this does for me is I can now identify that thing right there as my du. Okay, because that's what I have right there. So that's my du, and I can now start to write this in a simpler form. So what now if I write this as minus the integral 1 minus, and remember u was cosine, so cosine squared would be u squared du. Now I just have the power rule to deal with. So this is going to be minus, and if I use the power rule and undo it, the antiderivative of 1 is simply u. The antiderivative of u squared is going to be 1/3 u cubed, because when I take the derivative, the 3 comes down, cancels the 1/3, and I'm left with u squared. Okay, that's just the power rule. And then, of course, plus c. So now I just have to put everything back together. So I'm going to have minus the quantity. U, recall, was cosine, minus 1/3, and this is going to be cosine cubed of x, plus c. Now let's check it and make sure that it's working. Let's take the derivative with respect to x. I'm going to have minus the quantity. Let's go get my cosine. Cosine x, close that parenthesis, minus 1/3 times the cosine cubed. So I'm going to get cosine of x. Be careful not to put the cube inside the cosine function. So I'm going to close off the cosine function before I raise it to the third power. Okay. Hop down out of the exponent there, close that guy off. Now if all sits well with the world, I should get back my sine cubed. Looks a little bit different, right? Because I really expect to get back to where I started, which is my sine cubed x. So the question is, did we make a mistake, or is it just written in a different form? Well, let's see if we can manipulate this guy to make it look better. There is a couple commands in the algebra menu. If I go to the algebra menu, oops, and I go down to trigonometry, there's a trig collect command. Let's see what it does. Let's do trig expand. There's actually nothing wrong with the way it's written. We're just trying to show that these are the same. Now let's try to collect it. Let's see what happens. I did expand, right? Let's try trig collect to that thing, see if it simplifies it. It's not simplifying it, but let's just try this. Sine of x cubed equals, let's go up and get our original answer. True. So they really are the same. Okay, if we manipulate them enough, for example, this sine squared we could replace with 1 minus cosine squared. There's lots of things we could do to simplify it. It's perfectly good. There's nothing wrong with this answer that we got. It's just I was trying to make it look like what we started with. Okay, but they are the same. So either way we do it, we get the same. If we actually tell the machine to integrate it for me, so we can tell the machine to integrate the original sine cubed, sine of x cubed respect to x. Okay, it's giving this to me in this form, which is not the same as what we had entered before. If I go up here and grab this guy here, highlight him and pull him down, say equals that guy, of course it will say true because they are the same thing. So it may look different, but they are exactly the same algebraically equivalent expressions.